Hello, in this video segment we are discussing digital inputs and outputs. So what are some examples of digital inputs and output devices that are found with PLC systems? These are examples of digital input devices. You have push buttons, which can be used to start or stop a control system. Limit switches and proximity switches can indicate that a component is either in position or out of position. And motor starter contacts provide feedback that tells the PLC that a motor is either running or not running. On the right are voltages and types associated with digital input devices. 24 volts DC is the most common voltage type used today, as it is safer to work with than 120 volts AC. However, many existing systems still have 120 volt inputs wired directly into the PLC. This is an example wiring diagram showing how input devices are wired to input terminals on the PLC. Syncing and sourcing describe how the current flows from the power source through the device to the PLC input terminal. Most commonly, you see 24 volts DC plus wired to the field side input device. The negative side of the power supply is wired to the input module common. Sourcing inputs are the opposite of that. The main thing to understand is that when the push button is pushed, it closes the contacts and power flows to input terminal 4. This indicates to the PLC that the button is pushed. Input 4 changes from a 0 to 1. Similarly, when the limit switch changes from an open to a closed position, input 6 changes from a 0 to a 1. What you're seeing now are examples of digital output devices. These are devices that the PLC will turn on and off based on program execution. Motor starters are devices that tell a motor to either run or stop. Solenoids are devices that typically control the opening and closing of valves. On the right are the voltages and types associated with output devices. Just like inputs, 24 volts DC is the most common voltage type used today. Notice there are 3 types of outputs. Relays outputs contain a physical set of contacts that open and close with the PLC. Relay outputs can handle output devices that draw more current compared to, say, a triac or a transistor output. Relays can also handle both 120 volt AC and 24 volt DC. Triac and transistor outputs are typically used to cycle an output device on and off more frequently. With sourcing outputs, 24 volts DC plus is wired to a terminal that will supply power to the output terminals, which will in turn turn the output devices on and off. Notice that the negative is also wired to the common terminal for the outputs. When the program tells output 1 to turn on, power will flow from the plus VDC terminal to output terminal 1. If the solenoid valve needs to close, it will remove power from output terminal 5. With relay type outputs, there may be a supply terminal for each output terminal. This is known as isolated relay outputs. In this case, we're supplying output 1 with 24 volts DC plus to control a pilot light. In this diagram, you can see the representation of a relay internal to the PLC controlling the pilot light. When the program tells output 1 to turn on, it energizes the internal relay. This will allow power to flow through the contacts of the internal relay to output 1. Isolated relay outputs also allow the mixing of voltages on the same output card. As you can see, the solenoid controlled by output 3 requires 120 volts AC to operate. It is important to understand that power used to power up the electronics in the PLC is typically not the same power supply for the outputs. Power to the output circuit is typically isolated and may be turned on and off with a safety device, like an e-stop circuit. This would ensure power is removed even if the PLC was telling the output to turn on. This also allows you to remove power from all of the output devices without turning power off to the PLC. In this example, we are summing up the major components of a PLC, which include inputs, outputs, the CPU, and memory.